Temperature. Section 3.3. Temperature is a measurement of how hot or cold a substance is. Temperature is not heat. We will talk about heat as a form of energy in the next section. Temperature, how hot or cold a substance is. It has units that are not energy units, temperature units. 3 basic scales we have for temperature. Fahrenheit, U.S. customary system unit. We will not use that unit in science, but it's one that you're familiar with because it exists here in the United States, and we need to be able to convert from Fahrenheit to metric units of Celsius and Kelvin. Now, Fahrenheit and Celsius both have the degree symbol in front of the letter C and F, respectively. Celsius scale is sometimes called the centigrade scale as well. Kelvin, no degree sign in front of the capital letter K. That's not a mistake. That's intentional. That's how the temperature symbol is written for Kelvin. The Kelvin scale is an absolute temperature scale, meaning you do not have negative numbers. With Fahrenheit and Celsius, you can have negative numbers. With Kelvin, we do not. We'll talk about the Kelvin scale in a little bit. We must be able to convert from one scale to the other. And we will learn the formulas and do examples of converting temperature from one scale to the other. Let's learn how to convert from Fahrenheit to Celsius and from Celsius to Fahrenheit, vice versa. Okay? To get the Celsius temperature from the Fahrenheit temperature, take the difference of the Fahrenheit temperature minus 32. That difference divided by 1.8. Okay? To convert from Celsius into Fahrenheit, 1.8 times whatever the Celsius temperature is, multiply that, then add 32. Now, we're going to do examples. When you put this in your calculator, if you do a number minus 32 and then do the division sign, you're not following the order of operations. You need to get this difference and then divide by 1.8. So if you don't enter out or you do not put the parentheses, you will get the incorrect answer. So make sure you use the parentheses or enter out after you get this difference. Let's do a few examples. Today's temperature is 64 degrees Fahrenheit. What is it in degrees Celsius? 64 minus 32, that difference, divided by 1.8. So put it in your calculator, 64, okay, minus 32, okay, and you can enter that out and then divide by 1.8, okay, and you get a non-terminating, you get a repeating decimal, 17.77, okay, so forth, degrees Celsius. Let me show you with the parentheses. You can do it in one step. Open parentheses, 64.0 minus 32, close a parenthesis, divide by 1.8. Okay, get the same thing. Now, we learned about significant figures in chapter 2. It does not go away. This measurement had a decimal to the 10th place. So if we report this with proper significant figures, 17.8 degrees Celsius. Okay, 1 decimal place. Okay. It's a very easy calculation, but sometimes people, they do it in the calculator and they get answers that they shouldn't get. So you can use your calculator in this course. We'll be doing math that is much easier to do with a calculator. I know that some of the math courses, they don't permit you to use calculators, but we need to do a lot of math and with applications, so the calculator is quite useful in chemistry. You want to make sure that you can use it right. Okay, and if you have questions about your calculator, I can always try to help you out. Let's do another temperature conversion. Water boils at 100 degrees Celsius. What is the temperature in degrees Fahrenheit? I have 3 significant figures here with a whole number. I have the decimal here, meaning that these zeros are in a number that comes after a non-zero number with a decimal. 3 significant figures here. Well, let's do the math first. Let's find the temperature in Fahrenheit. 1.8 times 100 degrees, that product, add 32, you get 212 degrees Fahrenheit. Okay, very easy formulas to use. Okay, so that's how we convert from Fahrenheit to Celsius and from Celsius to Fahrenheit. Some of you may have learned the 5/8 and the 9/5. It's the same thing. Okay, 1.8 is the same as 9/5. Okay, and this is the same as dividing Fahrenheit minus 32 times 5/9, the reciprocal. It's the same thing. Okay, just in case in your past you've learned it with the fraction. Okay, well, let's talk now about this Kelvin scale. What is this Kelvin scale? Let's talk about that next. What is the Kelvin scale? The Kelvin scale is an absolute temperature scale based on the lowest possible degree Celsius temperature. An absolute value, when we say an absolute temperature scale, we mean how far from zero, no negatives, okay? 0 Kelvin, 0 K, is equivalent to negative 273 degrees Celsius. Okay. So the formula to convert Celsius to Kelvin and to convert Kelvin to Celsius is just the addition or subtraction of 273. To get Kelvin from a Celsius temperature, you add 273. To get Celsius from Kelvin, you subtract. Let's look a little bit more in detail at these three temperature scales. On the Fahrenheit scale, water boils at 212 Fahrenheit. We just did a problem where we calculated that. Room temperature is typically 68 degrees Fahrenheit, and water freezes at 32 degrees Fahrenheit. On the Celsius scale, water boils at 100 degrees Celsius, room temperature typically 20, and water freezes at 0 degrees Celsius. The Kelvin scale, water boils at 373 degrees Celsius, room temperature typically 293 Kelvin, and water freezes at 273. Look at the difference with the Celsius and the Kelvin scale for water boiling and water freezing. For the water freezing and water boiling on the Celsius scale, you have a difference of 100 degrees. If you look at the Kelvin scale, the difference between the water boiling and the water freezing is also a difference of 100 degrees. If you look at the difference on the Fahrenheit scale, water boiling and water freezing, you have a difference of 180 degrees. The Kelvin scale is based directly off of the Celsius scale, but we do not have any negative numbers on the Kelvin scale. The lowest possible temperature is 0 Kelvin. The Kelvin scale we use primarily for calculations involving gases. We will use exclusively temperatures in Kelvin when we get to chapter 11. Okay. You may wonder, negative 273, that's pretty cold. Okay. Well, I can tell you from personal experience that I used to work with in the lab a combination of acetone and dry ice, which is solid carbon dioxide, for a reaction that the temperature needed to be negative 78 degrees Celsius. So I've worked with those very low temperatures firsthand. Obviously not negative 273, but negative 78, it's pretty cold. And you have very cold temperatures at the North and South Pole as well. Requires use of protective gear, obviously. When I worked with the dry ice and acetone at negative 78 degrees Celsius, I had very heavy gloves on to protect my hands. Now we're going to just do a few sample calculations with these formulas right here. Okay. Okay, let's do a few, two examples with conversions Celsius to Kelvin and vice versa. Before we do that, I just wanted to show you a thermometer, a Celsius thermometer. I know it's hard to see in the video, but this Celsius thermometer actually can measure down to negative 100 degrees Celsius. Oh, you can't see it. You'll have to take my word for it. You might wonder what's the red material in here. It's an alcohol. I'm not sure which one it is, but it has a red dye in it. Mercury thermometers are not widely used at all anymore because of, they break and the mercury comes out and people are exposed to it and the hazards associated with mercury exposure. But you know, this here is a thermometer, a very cold temperature thermometer, down to 100 degrees Celsius. All right, let's just do quick calculations. A reaction in a lab setting was carried out at negative 78 degrees Celsius. I was just telling you about that. It was a real life scenario for me once upon a time. What is this temperature in Kelvin? Take the Celsius temperature and add 273. Negative 78 plus 273. We have a fair amount of negative numbers in science. Okay, you will see negative numbers and you will see negative temperatures. So you add negative 78 plus 273 and you get 195 Kelvin. Another number that comes up a lot in science is this 295 Kelvin. Reaction conditions at 298 Kelvin. Okay? Many reaction conditions call for a temperature of 298 Kelvin. What is this in degrees Celsius? You take the Kelvin temperature and you subtract 273. So 298 minus 273 gives you a Celsius equivalent of 25 degrees Celsius. So something that you see quite often in word problems in chemistry. Okay? It's a little bit warmer than room temperature. Okay? Be sure to look at the textbook. It gives a little bit more information, has some nice figures as well, some drawings, illustrations, and information.